Welcome back. This video is going to deal with how do you deal with significant figures in terms of any kind of calculation. And this is what's going to go with you for the rest of the year. So these are basic skills that we want you to make sure that you have mastered. Okay. Basically what's going to happen here is you're going to get a series of measurements, and then very often you're going to have to do a calculation associated with it. So you're going to have to determine which numbers mean something and how accurate can your answer be. And so if you take a look at this, we're going to first start with adding and subtracting. And adding and subtracting is the one that's probably the most difficult, because instead of looking at how many significant figures you're looking at where the significant figures are. So if you take a look at this first example right here, let me make sure I get an actual pencil this time. I'm going to subtract the two numbers, and to be honest with you, the easiest thing to do is to set the two numbers up like this, so that you have your decimals in the same place. Because now when I look at this, do you see how this is what, the 10th, 100,000th? This number is good all the way to the 10,000ths. That's how accurate. This would be a very precise measurements. You would have to have some really good metric meter stick or caliper or something of that nature to be able to measure that. Now compare that to the next measurement, and you can see that it goes to the 10th. Now, does that zero count? It is to the right of a non-zero. It is to the right of a decimal point. It matters. And so in this case, this number is only accurate to the 100th. When you add or subtract, this is going to be the thing that determines it, the fact that you can only go to 100th. So let's go ahead and let's see, so this is going to be 2.3478. Okay, if I put that in my calculator, that's what I would get. And if you put that down as an answer, you would be incorrect because you're not using the appropriate number of significant figures. So the best that this guy can go to is to 100th. That means that's the best my answer can go to, which means we're going to have to round this guy to 2.35. Now, if this was all I wrote down on the assignment, I would lose a point. And the reason I would lose a point is because I did not include units. So we need to make sure we include units. All right, let's go to the next one. And again, I would rewrite these. So I have 27.5 plus 2.2. And you'll notice that both of these are accurate to the 10th place. So when I add them, I'm going to get 29.7. This is accurate to the 10th place. This is accurate to the 10th place. My answer can go to the 10th place. I need to remember to use units, and I've got seconds. So I've got three significant figures. Now notice, this number has three significant figures, while the 2.2 has two significant figures, and yet my answer has three significant figures. So now let's scroll up and give ourselves a little bit more room. And we come over here, and I have 130. I have 130 plus, and this is going to be 12.4. This zero, is it significant or is it a placeholder? It is a placeholder, which means the best that this number goes to is to the 10 spot. This guy goes to the 10th spot. He's my weakest link, the 130, which means that's the best my answer can be. Now, if I threw this in my calculator, I would get 142.4. But if we put that down on the paper for our answer, we would be incorrect, because the best this can be is to the 10th place, which is going to make this 140 meters. All right, we've got 1.552 minus 0.23. Which of these two numbers is going to dictate how accurate our answer can be? I throw this in my calculator. I have 1.3, how about 22? But I can't write that down because some of these are not going to count. So which one of those digits will not matter? And it's going to be that one, because The 0.23 only goes to the hundredths place. That means that's the best my answer can be. My answer would be 1.32, and that would be grams. All right, so that's adding and subtracting. Next, we go to multiplication and division, and this one's kind of nice because all you have to do is you have to look at how many significant figures you have, and whichever number has the smaller number, that's the best your answer can be. So we've got this 3.540. How many significant figures are in this number? And the answer is there are 4 significant figures. That 0 counts. And this guy has 2 significant figures. I throw this into my calculator and I bet I get, how about this? I get 4.956. And wouldn't it be lovely if that would be a correct answer? But it wouldn't, because I only can have 2 significant figures in my answer, which means I need to round this to 2 significant figures, which is going to make that 5.0. That 0 is significant. It's to the right of a non-zero. It's to the right of a decimal. Look, I don't have units there, so that's kind of strange. All right, last but not least, let's do division. I'm going to take 25.45. I have 4 significant figures here. 1.04, I have 3. The best my answer can have is 3 significant figures. I put this in my calculator, and I get 24.47115838. 5. Wow, that's a lot of numbers that is in my calculator. And yet when we're doing measurements, most of those have no meaning. They're just a mathematical computation. But as far as telling you how accurate your number is, it doesn't tell us anything. I need to round this to 3 significant figures. That's going to give me 24.5, and that would be grams per milliliter. Now look at the difference here. Doesn't that seem like a reasonable measurement that you could make? The density of something is 24.5. Do you really think that you would have the typical equipment that would permit you to get measurements so precise that you could go way out here into the billions almost? All right, you should be on your way now. See you next time.